friends, welcome to my channel. So in the today's lecture, we are going to discuss static partitioning. Static partitioning. Static partitioning is a method of contiguous allocation. Okay, we are trying to find out the ways in which we can manage multiple processes in the main memory. Okay, so what we are doing in static partitioning, as it is clear from the name static. Okay, static means fixed. Static means fixed. What we want multitasking. We want to execute many number of processes at the same time. So what we have to do to perform multitasking? We have to keep many number of processes into the main memory. Okay, so the question is how we can manage multiple number of processes in the main memory. Okay, so what we are doing? What could be the simplest way to keep multiple processes in the main memory? Divide your main memory into the fixed partitions. Okay, we are going to divide the main memory into the fixed partitions. Okay, like this. I am dividing the main memory into this, like 8 KB, 3 KB, 2 KB. Okay, whatever main memory I am having, I am dividing this main memory into many number of partitions. Okay, so this is a very simplest way. If you want to execute multiple processes, we are going to keep all of that processes in the main memory. Each partition is going to hold one process. Okay, so let's suppose we have these 4 processes that want to execute. Your first process needs 6 KB. Okay, the size of your process 1 is 6 KB. The size of your process P2 is 3 KB. Size of process P3 is 1 KB. And size of process P4 is 2 KB. Okay, we have these 4 processes that want to execute. We have divided our main memory into fixed size partitions. Okay, so the first question is how to divide your main memory into partitions. Okay, so should we use random number to divide the memory into the fixed partition? So the best way to divide your main memory into fixed size partitions is keep all kind of partitions. Okay, you keep both kind of partitions, small partitions, large partitions. Okay, we should take mixture of all kind of partitions, small partitions, large partitions. Okay, what we want to do? We want to reduce the wastage of the main memory. Okay, we don't want our main memory to be wasted. So we should divide our main memory in such a way that we can utilize the main memory space at its best. Okay, so I have these 4 processes that want to execute. So what I have to do? I have to load all these 4 processes into the main memory. Okay, we have to load all of these 4 processes into the main memory. Okay, so if you look at, you have 3 KB. Your process P2 size is 3 KB. Okay, 3 KB can be stored in this partition, 4 KB partition. You can keep your process P2 in 8 KB partition, or you can store your process P2 in this partition. Okay, so what we have to do? We have to reduce the wastage of main memory. Okay, we have some algorithm. We have some algorithms with the help of which we can assign main memory to the processes. Okay, we have many ways to assign memory to multiple processes, because your one process, according to its size, it can be kept in many number of partitions. If you look at your 2 KB process, can be kept in this partition, this or this. So your one process can be kept in many number of partitions. So the question is, how to assign main memory partition to the process? Which algorithm we should use? We basically have 3 algorithms to assign main memory partition to process. We have firstly first fit algorithm, we have best fit, and third one we have is burst fit. Okay, these 3 algorithms are there to assign main memory partition to the process. Okay, what is the meaning of first fit? First fit means which partition, which is the first partition to hold your process. Okay, which is the first one partition to hold your process. If you look at it, if I use first fit algorithm, I have a process P1 6 KB. Okay, so which is the first partition to keep 6 KB process? This one, this 8 KB. Okay, so your process P1 is going to be stored in this partition. This is the first partition to keep 6 KB process. Okay, so if we are using first fit algorithm, we are going to store process P1 here. Okay, process P2 size is 3 KB. Okay, so which is the first partition to store 3 KB? If you look at it, this first partition size is 4 KB. 3 KB process can be stored by this partition, this 4 KB partition, as well as this partition, this 3 KB partition. But I will be storing my process in that partition which is the first one, partition. Okay, so I am storing my process P2 here. Okay, I am going to store my process P2 here, and my 1 KB of main memory space is going to be wasted. Okay, so next we have process P3. Okay, the size of process P1 is, the size of process P3 is 1 KB. This process P3 can be kept at this partition, 3 KB partition and 2 KB partition. But I will be storing my process P3 in the first partition. Which partition is the first one? process P3 in this 3 KB partition. So 2 KB of main memory is going to be wasted. Okay. Next I have process P4. The size of process P4 is 2 KB. Okay. And I have just only one partition left. Okay. So your process P4 is going to be kept in this 2 KB partition. This partition is capable enough to store your process P4. So I am storing my process P4 in this partition. Okay. So if you look at it, if you are using the first fit algorithm, how much memory space you are going to waste? Okay. How much memory space we are wasting? Process P2 size is 3 KB. Here I am wasting my 1 KB size. Your process P1 size is 6 KB. Okay. And I am wasting 2 KB space here. My process P3 size is 1 KB. Okay. So 2 KB space is going to be wasted here. So total 5 KB space is wasted. We have to reduce the wastage of the space. We don't want to waste our main memory space because each of your partition is just going to store only one process. Okay, so you should choose wisely which algorithm is best one for the maximum utilization of your space. Okay, so let's suppose if you have a partition of 8 KB and you are just storing 1 KB process in that 8 KB partition. So obviously this is not a good decision. Okay, your 7 KB of main memory space is going to be wasted. You cannot store multiple processes in a one partition. Okay, so we have to choose wisely that which partition is best for which process. Okay, so next we have best fit. Okay, first fit algorithm is which is the first partition capable enough to store your process. Next we have best fit algorithm. Okay, next we have best fit algorithm. So what is the meaning of best fit? Best fit means which partition is best for the process. If you look at your process P1 size is 6 KB. Okay, your process P1 size is 6 KB. So out of all this, which partition is suitable for your process P1? So if you look at this 8 KB partition is suitable for your process P1. Next process we have is P2. The size of process P2 is 3 KB. Okay, so which is the best partition to save process P2? Okay, so this 3 KB is the best partition to save the process P2. In best fit algorithm, we try to reduce the main memory wastage. Okay, we try to reduce the wastage of main memory. So for process P2, this is the best partition. If you are storing your 3 KB process in this 3 KB partition, no space is going to be wasted. It is going to be completely fit inside this partition. Okay. So next we have process P3. The size of process P3 is 1 KB. Which is the best possible partition to store 1 KB process? I have these two partitions, 4 KB and 2 KB. If I store my process P3 in 2 to be wasted. Next, we have process P4. The size of process P4 is 2 kb. So now I don't have any option. Only one partition is left. I cannot make any choice. So I have to keep my process P4 here. Okay. My 2 kb is going to be wasted. Okay. So this is actually our best fit algorithm. We just try to reduce the wastage of main memory space. So this is the good algorithm. Best fit algorithm is really good. Okay, it is going to reduce the wastage of your main memory space. Okay, so next we have worst fit algorithm. It is completely opposite to the best fit. Best fit, you just try to find that partition for your process so that we can reduce the wastage of main memory space. But worst fit means you intentionally want wastage of space. Okay, you don't want to reduce the wastage of space, even you intentionally want your main memory space to be wasted. Okay, if you have a 10 kb partition and if you have to store 1 kb partition, you will be storing intentionally that 1 kb partition in your 10 kb. Okay, so let me show you how worst fit algorithm is going to work in this case. We have first process P1. The size of this process P1 is 6 kb. So in this, we just have only one partition to store 6 kb process. We don't have any options. Okay, so I am keeping my process P1 in 8 kb partition. Next, I am having process P2. The size of this process is 3 kb. If I store my 3 kb process in this partition, then there is no problem. Okay, no space is going to be wasted. But in worst fit, I intentionally want my space to be wasted. Okay, so what I am going to do? I am going to save my process P2 in this 4 kb partition. Okay, my 1 kb is going to be wasted. Okay, my 1 kb of space is going to be wasted. Next, I am having process P3. The size of this process P3 is 1 kb. Okay, if I store my 1 kb process in 2 kb, only 1 kb is going to be wasted. If I store 1 kb in 3 kb in partition, so 2 kb is going to be wasted. In worst fit, I intentionally want more space to be wasted. So I am storing my process P3 in this partition. Okay. Next I am having process P4. So only one option is left. Okay. Only one partition is left. So I am storing my process P4 in this 2 kb partition. So worst fit and best fit both are opposite of each other. Okay. Best fit means we are storing our process in that partition so that we can reduce the wastage of memory. But in worst fit, we are trying to store our process in that partition so that our loss of memory space is going to be wasted. So, best fit algorithm is good if you want to reduce the wastage of main memory space. So let me give you one real life example of static partitioning. Okay, so what you have to do, let's suppose you are preparing for your exam. Okay, we have to prepare for computer networking operating system and DBMS. What happened in static partitioning? In static partitioning, I have divided my hours, that for how many hours I will be studying computer networking, like this 4, 3, 2. Okay, I have 3 hours I will be studying operating system, and for 2 hours I will be studying database management system daily. Okay, you have divided your time. Okay, you want to study multiple subjects. Okay, you want to study many subjects parallelly. So what we have done, we have divided the time. That for these many hours I am studying computer networking. For these 3 hours I am studying operating system. So you can consider it as a real life example. In real life, if we have to perform multiple tasks at the same time, okay, what we can do? We can divide time. That for these many hours I will be studying this subject, and for these hours I will be studying operating system subject. Okay, so that we can execute multiple tasks at the same time. So this example you can consider in the static partitioning. Okay, so I hope that you are clear with static partitioning. So thank you so much for watching my video. If you like my video, please like, share and subscribe my channel.